All right, this is the video for problems 6 and 7. We are almost done. Yay. All right, these are really similar, so I'll try to cram them in one video. The two cylinders below are similar. Find the following information. So similarity ratio from small to large. So if my small is 20 and my large is 28, I could write it this way or this way. I want you to reduce those. So we could factor out the greatest common factor, or you can do math enter in your calculator. Looking at these, I know they're both divisible by 4. So 20 divided by 4 is 5. 28 divided by 4 is 7. So 5 to 7. All right, for the ratio of the areas, remember we've got to square that. So don't just write 5 squared over 7 squared, but I want to see 25 over 49. Ratio of volumes, we're going to cube our similarity ratio. So actually write it out as 125 over, I'm pretty sure that that's 343, but let's double check. Yeah, 343. All right, so that's the ratio of our areas and the ratio of our volumes. So then you're asked to find the surface area of the large cylinder, and we're given the surface area of the small cylinder. So if we find the large, we could set this up and say, all right, the ratio of the areas from small to large is 25 to 49. And if we know that the small cylinder has a surface area of 150, that's going to go on top. We're going to solve for x on the bottom. So cross multiply, 49 times 150 is 7,350, and that's going to equal 25x. Divide both sides by 25, x equals 294 yards squared. So the surface area of the large cylinder, which we didn't know before, and it tells you here the large, so we know that was the small, and it's under the small, is 294 yards squared. Then we're given the volume of the large and asked to find the volume of the small. We're still going to use a proportion, but we're going to use our volume ratio. So small to large is 125 to 343. The volume of my small is unknown. The volume of my large is given, 3,087 cubic yards. We're going to cross multiply. So 343x equals, 385,875. And when we divide that by 343, we get x equals 1,125. So 1,125 cubic yards, because it is a volume. Awesome, you've got one more practice problem, pretty much just like that one, except it is not two-dimensional, or three-dimensional, excuse me, it is two-dimensional. All right, so we're asked to find the similarity ratio. You wanna make sure you choose corresponding sides. So for example, I noticed that 18 and 15 are in the same position, and then I noticed that like 42 and 35 are in the same position. Because you're gonna have to simplify it, use the smaller numbers. If you can, use the smaller ones. And we're going small to large. So we're gonna say our ratio is 15 to 18, but we can simplify that. Those are both divisible by 3. So 15 divided by 3 is 5, 18 divided by 3 is 6. Our similarity ratio is 5 to 6. The ratio of the areas, we know we're just gonna square that. 5 squared over 6 squared gives us 25 over 36. I do want you to square those. And then we're not asked to find the ratio of the volumes because they don't have volume. They're two-dimensional. So now we're asked to find the area of the large shape. We're given the area of the small. So if I set up my ratio, small to large, I'm given the small, 350 square units. The large is my unknown. cross multiply. 36 times 350 is 12,600. That's equal to 25x. Divide both sides by 25. X equals 504. So the area of the large shape is 504 units squared. I'm just going to put a U there. Then we're asked for the perimeter of the small shape. And I'm not sure we practiced this in class exactly, but just think about it. Perimeter, it's not a volume. It's not an area. It is a linear measure. So for the perimeter, we're going to use the similarity ratio. So we're going to say from small to large is 5 to 6. We're given the perimeter of the large, so our small is unknown. So our variable goes on top. 6x equals 108 times 5, which is 540. Divide that by 6. X is 90. So the perimeter of the small shape should be 90 units. All right, that is it. Make sure you bring this at the latest on the day of your final, if not sooner.